So once we've built a model, what we really want to do is run some test data against it to see how well it performs. I mean, it's wonderful to train a model on and see the results of training it on data that it knows, but we want to see how well it generalizes against data it hasn't seen. And Darwin makes it really easy to do this. So we follow essentially the same procedure we did before. This time we're going to upload our test data, which is also in the Darwin SDK, that repo you clone down. We upload this data, and then we call that method run model. And now when Darwin runs this, it's going to run much faster because it's just bouncing this test data against our already trained model and returning the results. And when we look at this, and this is all just Python code here to interpret the results. So it's not, again, not required, but it just makes viewing the results here a little easier. What we're seeing is a confusion matrix. And this confusion matrix shows the difference between the model's precision and recall. And what you want to see is a nice balance between the two. So precision is the number of false positives. So you want a model that's relatively accurate. And at the same time, recall is it finding all of those malignant cases that we're actually looking for? Now, in our case, we looked at the value counts between malignant and benign. We saw that while they weren't split, they were fairly close. So it's nice to see that our confusion matrix here reflects that we have some parity here as demonstrated in this F1 score. Now, this is against, again, the test data. So the Darwin model, the Darwin trained model, has not seen this, and it's performed very, very well against this test data. So we can be fairly confident moving forward that we've built a good model, or that Darwin has built one for us. And if we want to look under the hood and see exactly what model Darwin chose to run, we can call this method lookup model name. Yeah, aptly named. And what we see is that Darwin chose a deep neural network. And I want to point out a few things about this because this is getting more to the guts of what Darwin's doing and this is cool stuff. So the input features here are in this first layer of the deep neural network are 82. And if you recall, looking at our spreadsheet, we didn't have nearly 82 columns. So what Darwin's doing, and these input features change for each row, Darwin's doing some feature engineering that we talked about for us. And it's also doing some hyperparameter optimization. So it's deciding how many input features to generate and then how many output features the model at each layer should have. And you can see these numbers adjust. And it is deciding this, right? It's going through these different training cycles and figuring this out. And ultimately, we're only interested in one of two output features, right? And that's why the final layer here, which Darwin inferred from our data set, we didn't have to tell it, inferred was either malignant or benign, and it figured this out. But along the way, these are the numbers it came up with for input features and for output features. And again, we did none of this. We didn't have to bother with it. And if you were to do this on your own with different deep learning frameworks, you would be inputting these features. You would be testing this out. You would be running a bunch of different training jobs and validation sets. This would be very time consuming. And again, Darwin just took care of all of this for us. So I think at the end, what you've seen is that Darwin's automated not only the data cleaning, the feature extraction, but the model optimization. So as someone who may or may not be really familiar with these machine learning models, it doesn't matter. With Darwin, you can quickly generate powerful models. And I hope you've seen that in this example. If you have not signed up yet, get started with your 15-day trial right now by clicking the link in the description of the video.